on that basis our chapter will be. We'll do the numericals. So children, the numericals that we will do today will be on temperature conversions. Okay. And temperature conversions that you will be evaluated for would be only from degree Celsius to Kelvin. And how do you do it? 0 Kelvin is said to be minus 273 degrees Celsius, or 0 degrees Celsius is equal to 273 Kelvin. Okay, these are the things which we will take in our study today. This is one. Kirtan, your camera is off. After that, we went to our gas laws. And one law I am still to explain you. While your book does not take the name, they say that this is the law which connects pressure and volume. So this law is known as Boyle's law. Boyle's law. What does Boyle's law tell you? Boyle's law tells me that pressure is inversely proportional to volume as long as number of moles and the temperature are kept constant. Easy to understand. Do you recollect? If you give pressure to a cylinder, the volume becomes small. So from this we get a relationship. P into V is always equal to constant. The way we will use it in our mathematical problem would be P1 V1, that is some scenarios pressure and volume will be equal to the other scenarios pressure and volume. This will how we'll go for numericals. Anyone has any doubt in whatever I have written so far? Boyle's law. How many of you did those two problems? Now this is 2 weeks gone. Those two problems that I gave on titration on Skype, no one has done. Nobody has given a look also. That's the problem. Dhruv, you did it. You got the answers. I've given the answers also. Right. Very good. Okay. After that, we came to Charles' law. Charles' law. Charles' law connects volume with temperature. It says that the volume occupied by a gas is directly proportional to temperature. If you increase the temperature, the volume increases, provided the number of moles and the pressure both are kept constant. That is, mass of the gas is kept constant and pressure kept constant. So if you want to have the same pressure, then you have to allow the volume to increase. If you don't allow the volume to increase, the pressure will build up. Are you able to understand? So from here, the relation we will get is V by T will be equal to constant. That means scenarios will come up as some V1 by T1 will be equal to some stage V2 by T2. Okay. If we talk in terms of graph, a PV graph will always look like this, whereas a P over 1 upon V graph will always look like this. A VT graph will always look like this. And in these problems, remember the temperature should always be in Kelvin, not in Celsius. Today we are going to learn about the third law. So as I told you, in these gas laws, we are going to study about the parameters of pressure, volume, temperature, and number of moles. This will come a little bit in higher classes, but we're going to study about these three. So in the first one, you played between P and V. In the second one, you played between V and T. So the only combination that is left is pressure and temperature, right? So in the third one, we'll play about pressure and temperature. Can I wipe this off? This is what we have already done. Okay. And whenever we are dealing with temperature, remember all temperatures are in Kelvin scale, right? So the third law is known as Gay-Lussac's law, although the book does not mention this name. Gay-Lussac's law. So Gay-Lussac's law says that the pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Imagine that I have got a piston and I don't allow the piston to expand, right? I don't allow the piston to expand. And I keep on heating the gas inside. So don't you think the gas molecules are going to hit the container? Tuck, 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 tuck. The pressure is going to build up. Yes, so that's it. The pressure is directly proportional to temperature, provided the mass of the gas, which is contributed by the number of moles, and the volume is kept constant. Have you understood? Clear? If I have 10 notorious kids inside a room and I don't allow the room to expand, and the kids are within that room, and you increase their, what do you call, naughtiness, won't my blood pressure shoot up? Yes, my blood pressure shoots up. So the expression we are going to get from here is P over T will be equal to constant. Children, I hope you know this simple thing in mathematics. If x is directly proportional to y, x can be written as some constant k into y, which means x over y is equal to constant. And if we say that x is inversely proportional to y, that means x is equal to some constant k into 1 upon y, which means xy as a product is always equal to constant. Remember, this was what we used in PV. P is inversely proportional to V. Rest of the things we are having direct proportional. So out here I'll have P by T. So solving a problem, my scenario would be P1 by T1 will be equal to P2 by T2 when we solve it. Remember again, temperature should be in Kelvin scale, right? So let's see what are the three laws we have got with us. We have PV equal to constant. We have V by T is equal to constant. We have P by T is equal to constant. In other words, I can write something like this. P1 V1 is equal to P2 V2. I can write V1 by T1 is equal to V2 by T2. And I can write P by T1, P1 by T1 is equal to P2 by T2. Time has now come to combine the three laws also. First law was Boyle's law, Charles' law, Gay-Lussac's law. The book only tells name of Charles. They say it as a pressure-volume relationship, pressure-temperature relationship. Now we'll combine the three laws. So if you combine, how does it look like? P1, V1 is always on top. V upon T is a constant ratio. And P upon T is also a constant ratio. So if you combine these two, you can write P1 V1 by T1 is equal to P2 V2 by T2. This is when the three laws are combined together. See, the relation is maintained. P1 V1 equal to P2 V2. V1 by T1 is equal to V2 by T2. P1 by T1 is equal to P2 by T2. बस और कुछ नहीं पढ़ना है इस चैप्टर में. Apart from this, you should know gas conversion, what you call temperature conversion scales. So we will take some problems and we'll finish all problems in one go. So children, get your calculators on your hand and we start our problems. Okay. Okay, some more interesting conversions you should know. 1 Newton upon meter square is given by 1 Pascal. Ready? Okay, 1 Newton upon 1 meter square is given as 1 Pascal. Okay, this is one conversion that you will need, and I don't think we need any other conversion. So let's start with our problems. Okay, can I rub the board now? Okay, and we get with our problems now. And do as many problems as you can. Ye chapter se problems are more important for us. Okay. Now I won't tell you this problem is from Boyle's law, Charles' law, or Gay-Lussac's law, or combination, because in the exam you have to figure it out. And how do you figure it out? By the parameters which are given in this question, right? So let's see what is my first question. My first question is a certain quantity of gas. So I have a certain quantity of gas. This is a certain quantity of gas, and this gas has a volume of 40 centimeter cube, has a volume of 40 centimeter cube at a pressure of 1 into 10 to the power 5 Pascal. 1 into 10 to the power 5 Pascal. They have asked us, find the volume of this gas. Find the volume of this gas when the pressure is, don't solve the problem straight away, huh? When pressure is 2 into 10 to the power 5 Pascal. Now let's say it's a bad day for you at the exam hall and you have forgotten everything. Okay? You don't know what is Boyle's law, what is Charles' law, nothing you know. You only have, but you need to have some common sense with you. I have been given a pressure volume scenario, pressure volume relationship under two scenarios. Right? Now look at here. what is happening to the pressure in the next scenario? Don't you think 10 to the power 25 is same? So the pressure has been increased. So if you increase pressure, don't you think volume should reduce? Think about anything. But let's say Ashmita wants to go, our friend just came from Goa. So she must have taken a lot of clothes with her. So if she increases pressure, like she sits on the suitcase, don't you think the volume of the clothes are going to shrink? So we should get a volume which should be less than the initial volume. And a pressure volume relationship is given by Boyle's law. So what is the relationship between pressure and volume? Pressure is always inversely proportional to volume, which means pressure volume is always equal to constant. That means in a problem we will get scenarios where P1 by V1 should be equal to P2 by V2. Now, like good children, you can take this as your V1 and you take this as your P1, you take this as your P2, you take this as your V2. Can you solve the problem now? There is no temperature, children, mind you. There is no temperature. So half the headache is gone. Just make sure both the pressures are measured on the same scale and the volume is measured on the same scale. Can you do this problem now? इसको करने की जरूरत ही क्या है? ए, इसको डबल किया तो उसका हाफ होगा, खत्म. So it should be 20 centimeter cube. ध्रुव समझ में आया? प्रेशर को हमने डबल किया है, 1 की जगह 2 किया है, तो वॉल्यूम कितना हो जाएगा? हाफ हो जाएगा. So the volume should come as, still since you are doing, so let's do, so P1 by V1, V1 is equal to P2 V2, which means 1 into 10 to the power 5 into V1, which is 40, should be equal to P2, 2 into 10 to the power 5 multiplied by V2, 10 to the power 5, 10 to the power 5 gone, then 2 strikes it out as 20. That means V2 equals to how much? 20 centimeter cube. How did this fellow get inside? Centimeter cube. Are we fine? First problem, easy, not that difficult. Okay. Just you have to ensure that the relation that you are taking. He has got a cockroach life. Shall we go to the next one, bacha? Chali. Next question. Now you need to do this. A fixed mass of gas. Okay. Now next question. My next question is, I have got a fixed mass. A fixed mass. Why did they say fixed mass? Because gas laws are applicable only when mass is constant. That is, number of moles is constant. Fixed mass of gas. This has a volume. This has a volume which is equal to 9 centimeter cube. And at that time, the pressure has been recorded as 1 into 10 to the power 5 Pascal. 1 into 10 to the power 5 Pascal. And they're asking you, find the volume when the pressure is, find the volume when the pressure is 3 into 10 to the power 5 Pascal. You need to do it. So you have made it 1/3. So you have jacked up the pressure 3 times, so the volume will fall by 1/3. Your answer should be 3 centimeter cube. Perfect. Okay, my next question. A certain quantity of gas, okay, this is also a gas, and this gas is a certain quantity. Certain quantity of gas has a volume of, this has a volume which is equal to 40 centimeter cube, okay, 40 centimeter cube at a pressure, at that time, the pressure is equal to 2 into 10 raised to the power 5 Pascal. Pressure of 2 into 10 raised to the power 5 Pascal. Now, at the next scenario, the volume has become 20 centimeter cube. You are supposed to comment on the pressure. So if the volume has become half, the pressure must have been doubled. So the pressure becomes 4 into 10 to the power. Good. You've got a good grasp now of Boyle's law. These were all problems on Boyle's law, because Boyle's law is all about pressure volume relationship. Samajh mein aaya? Kirtan, did you understand?
Yes, sir.
Good. Now you might be thinking, next problem sir will give from Charles' law, but now sir becomes a little bit crook. He will not give problems from Charles' law. Otherwise your predictability is there. Now let's make it unpredictable. Okay, fine. Can I rub this? Okay, let's go to the next set of problems. Let's do some conversions. Okay, let's do some conversions. (27 degrees Celsius) convert it into Kelvin. (60 Kelvin) convert it into degree Celsius. Do not write degree in Kelvin, okay? (80 degrees Celsius) convert it into Kelvin, and 100 Kelvin convert it into degree Celsius. Come on. Whoever has done can tell me the figures. I can write them so we can cross check.
So this is the first one, 290 Kelvin.
First one is how much?
290.
273 is 0. So 273, 0 degrees Celsius is 273. So you add 27 with it. 273 plus 27. How much are you getting?
300.
Yes, 300 Kelvin. 60 Kelvin means okay, if you need the conversion, once again, 0 degrees Celsius. 0 degrees Celsius is 273 Kelvin, and 0 Kelvin is equal to minus 273 degrees Celsius. So 60 Kelvin, you're getting 60 above here, so add 60 with it. So if you add 60 with it, it becomes how much? 3, 7 and 6 is 1 and 200. So it becomes minus 213 degrees Celsius. Not 213, minus. Minus hoga na?
Yes.
Okay. Next, 80 degrees Celsius. So add 80 with it. ऐसे करने से बेस्ट होता है. देखो अस्मिता, ऐसे करो. 0 degrees Celsius is equal to 273 Kelvin. You now want to make it 80 degrees Celsius. That means you have added 80. You just add 80 out here. So if you add 83, and the previous problem you see, 0 Kelvin gives me how much? Minus 273 degrees Celsius. Now how much did you want to find out? 60 Kelvin. That means you have added 60 Kelvin here. You add 60 out here. So if you add 60, it becomes how much? 3, 1, 2, negative. Okay. So how much is 100? You have added 100 out here. So add 100, it becomes minus 173 degrees Celsius. All of you fine? Conversions? Very good. Chalo. Let's take some more problems now. Okay. Next set of questions. I have a bicycle pump. I have a bicycle pump. So my bicycle pump contains 50 centimeter cube of air. This bicycle pump has 50 centimeter cube of air at 17 degrees Celsius. At 17 degrees Celsius, and 1 atmosphere pressure, 1 atm pressure, means under normal condition. That's 1 atmosphere pressure. Now find the pressure. Now you need to find the pressure. So find the pressure. Find the pressure when the air is compressed. The air has been compressed. Air has been compressed to 10 centimeter cube, and at that time, if I've compressed it, okay. Have you inflated your car tire ever? Car nahi, this bicycle tire. If you go on pressurizing your bicycle tire, have you touched that pump at that time? Kya hota hai? It's hot. So you are now compressing air. Apply common sense always. So the temperature should go up. So the temperature definitely goes up, and at the temperature of 27 degrees Celsius. So try and understand. I have a bicycle pump. The bicycle pump at 1 atmosphere pressure has 50 centimeter cube of air at a temperature of 17 degrees Celsius. Then you started compressing the air inside it, and you compressed it to some pressure which you don't know, you have to find out. The volume of the air after compression, ऐसे push मारने के बाद compress होके कितना हो गया 10 centimeter cube. 50 got compressed to 10. 5 times you have compressed it, and the temperature has gone up to 27. How will you solve it? Yeah, you will have to use, now see how many parameters are given. If I take this parameter, as volume 1, this happened at a temperature T1. Obviously T1 should be reported in Kelvin, mind you. अभी ये centigrade में गलत हो जाएगा नहीं तो. And during this time the pressure was P1. You do not know what is P2, and you know the volume V2, you know the temperature T2, but this has to be in Kelvin. Okay, remember that. Now the law that connects it is pressure, volume, temperature is equal to pressure, volume, temperature. Do it in proper way and get the answer. So in one go you can write it actually. You need to find P2, right? So P2 will be given as T2 by V2 times P1 V1 by T1. Okay, na? Equate. What is the value of T2? Tell me, bacha. T2 is how much? 27. That means T2 has become 300. What about V2? V2 is 10 centimeter cube. Always write your units. 300 Kelvin, 10 centimeter cube multiplied by P1. P1 is my pressure, which is 1 atmosphere, 180A, okay, into V1. My V1 is 50 centimeter cube upon T1, and my T1 is how much? 17. So 17 means 273. So 283 and 290 Kelvin. Now try to see your units first so that you are doubly sure. Kelvin takes away Kelvin, centimeter cube takes away centimeter cube. So the answer you are going to get will always be in atmosphere, and that is what is needed because you are trying to solve P2. How do you solve P2? 100, 0 takes away 0, and then this 0 takes away this. So it's 13 to 5 is how much? 150 divided by 29. Had it been 30, then its answer should have been 50. So it should be, karo abhi kitna hai? Had it been 30, the answer would have been 5. 5.1 or, okay, 17, that means 5.2. And the answer should be in atmosphere, 88. Sorry, 80M we write. We don't write 88. We write it as 80M. This is 80M. Perfect, bacha? All of you understood? And see, you can apply some common sense. Had this been 30, 30 into 5 times is 150. Just because you have a Casio, you should not be always so dependent on the Casio. Clear? Kirtan, did you understand? Children make only one mistake in these problems. They don't convert the temperature to Kelvin. Remember, all these laws are on absolute scale of temperature. ठीक है? एक और problem करते हैं. चलिए, आज तो problem दिवस ही है. So let's do one more problem. Next question. Okay, let's see what is our question. So my next question is, okay, 1 atmosphere, ये भी लिख के रखो, 1 atmosphere is equal to 10 to the power 5 Pascal. 1 atmosphere is 10 to the power 5 Pascal. Okay. Now, there is a fixed mass of gas. I have gas, and this gas is of a fixed mass. Fixed mass of gas, and this gas has a volume of, 9 centimeter cube, right? At a pressure of 1 into 10 to the power 5 Pascal, and at that time at a temperature of 27 degrees Celsius. Find the pressure when the volume is compressed to, the volume has been compressed to 5 centimeter cube. This has been compressed. I don't know what is the pressure, and at that time the temperature rises to at 37 degrees Celsius. Tell me, ये problem कीजिए. Getting a grip of it? Okay, good. As long as you'll understand, there is no problem. And the initial part of theory, don't forget to study what is Brownian motion, what is kinetic theory of matter. We have all done those in our chemistry classes. Aya, and don't just solve it up, solve it in proper manner. Write your equations. I am not hungry for the answer. I'm more hungry on your process. P1 V1 upon T1 equals to P2 V2 upon T2. You need to find P2, which is equal to T2 by V2 times P1 V1 upon T1, and include all your what is called the units. So my P2 equals to T2. T2 is 37. That means 310 Kelvin divided by V2, which is 5 centimeter cube, multiplied by P1, 1 into 10 to the power 5 Pascal, over T1. T1 is how much? 27. So that's 300 Kelvin into V1, which is 9 centimeter cube. Centimeter cube gone, Kelvin gone, pressure. So P2 equals to, so how much is it? The 0 takes away this 0. So this is 31 upon 30 into 1 upon 5 into 1 into 10 to the power 5. Solve this part. So this is approximately 1. So 1 by 5. 1 by 5 is 0.2. 0.2 into 10, so 0.2 atmosphere. 0.2 into 10 to the power 5, which is same as 0.2, roughly. But you still do. Use your calculator and get the right answer. Yes, Kirtan darling, are you getting or not, or only scratching head?
I'm sorry, I got it.
What answer did you get? Then why are you silent? Tell me.
1.86.
1.86. Yeah, it should be more than 1. 31 by 30 should be just marginally over 1. 1 upon 5. How much did you get? इसलिए हमेशा ऐसे लिखा करो. हाँ, how much did you get, Kirtan?
1.86.
So Kirtan is calling out the answer as 1.86 into 10 to the power 5 Pascal, which is same as 1.86. You can write this as atmosphere also based on this relation. Anyone else has got this answer? Check and confirm. Dhruv,
Yes, sir.
did you get the same answer as Kirtan?
No, I got 0.206.
0.2 should be the answer. Look, Kirtan, 31 upon 30 as a ratio is almost 1.
Yeah.
1 divided by 5 is 0.2.
Yeah.
And 0.2. So this cannot be the answer. That's why I'm saying ध्रुव कितना है आंसर?
0.206
0.21 into 10 to the power 5 Pascal. Anyone else has got this, which is equal to 0.21 atmosphere. Hey, Sasta, have you got your answer or not? कितना देर लगता है? Hurry, madam, 31 divided by 150 you do. Have you got the figure or not? And that's what I'm asking. Ashmita madam, did you get the figure? और क्या डूइंग है इसमें? खिचड़ी पका रहे हो क्या? 31 by 150 करो, कितना टाइम लगता है? Started in a wrong way because you all are all eager to get the answer and do the numerical. You have not followed the procedure that I have done. Shortcut करते हो ना खाली. ऐसे करो ना, क्यों गलती? I am doing with, I don't have any. निकालना कहाँ क्या है बेटा? P2 निकालना है ना. So first, this is your main formula. This is your adjusted formula. This is your substituted value. Make sure you write your units. Then the whole thing comes this. This is what P2 is equal to. I am saying this fellow should be approximately 1. Marginally over 1. 1 divided by 5 is 0.2. So 0.2 into 10 to the power 5.
Yes.
Nidhi madam, did you get the answer? Your face is still not saying you got it. But your Zabardasti is saying you got it. I'll wait for you. Get the pleasure of getting the answer. Then you'll feel confident to go ahead. क्या ध्रुव आया कि नहीं तेरे को?
Yes, sir.
कीर्तन?
Yeah, sir.
I got the wrong answer or I got the right answer now? Yes. Yes, Asmita, I'm waiting. The bus will wait for you. Don't worry. She's under tremendous pressure now to get the answer. Chalo, jaldi karo. Hey, Nidhi, did you get it or not?
I did.
Yeah, it's done. Yes, Asmita, your countdown starts now. 10, 9, 7.5, 6.5, 4. हुआ कि नहीं?
No, sir. 1 second.
Eh? Still no. I am waiting 1 second. Till you don't say, I'll not proceed. And in hurry, don't forget to convert the volume, the temperatures into Kelvin. Yeah. Done, Asmita. Hurry.
So last step.
Acha, last step. I want to see your workout, how you are doing it. हाथ में कैलकुलेटर होगी इतना टाइम लगता है? Are you rewriting?
Sure, I do this definitely. So I don't actually do it wrong. I did something wrong.
No, you cannot do something wrong. How can you do something wrong? तुम मेरे साथ लिखो. P1 V1 by T1 equal to, you write, you will do it in 4 steps, right? P1 V1 by T1 equal to P2 V2 by T2, right? P1 V1 by T1 equal to P2 V2 by T2. Have you finished writing this line?
Yes.
Now write what is P2 equal to, right? P2 is equal to T2 by V2, T2 by V2 into P1 V1 by T1.
Yes.
Yes, in place of T2 you write 310 Kelvin K.
Yes.
I am narrating from my memory. Instead of V2 you write how much? 5 centimeter cube, right? Yes, 5. V2 is 5. 310 Kelvin divided by 5 centimeter cube into P1. P1 is 1 into 10 to the power 5. V1 is 9 centimeter cube divided by
296.
how 296 Kelvin? 27 degrees Celsius is 300 Kelvin.
Also, that's what I missed. So then I messed up the.
What messed up? You say don't give all this chalu English word messed up. Say I calculated Kelvin wrongly. What is that messed up? हाँ तो इसलिए 3 बार में आंसर नहीं आ रहा है. बोर्ड से देख के भी रॉन्ग लिखते हो. चलो नेक्स्ट क्वेश्चन. A certain quantity of gas has a volume of 40 centimeter cube. So this has a volume which is equal to 40 centimeter cube, right? At a pressure of 2 into 10 to the power 5 Pascal. At 2 into 10 to the power 5 Pascal. ठीक है? 2 into 10 to the power 5 Pascal. Right. Find the temperature when the volume is 30 centimeter at 27 degrees Celsius. At 27 degrees Celsius. You need to find the volume and the sorry, you don't need to find the volume, you need to comment on the temperature. Comment on the temperature when the volume is how much? Now the volume is 30 centimeter cube. The volume is 30 centimeter cube and the pressure is 3.2. The pressure is 3.2 into 10 to the power 5 Pascal. अच्छा एक बार देखो प्रॉब्लम को, ऐसे सीधा सीधी करो मत. You have jacked up the pressure. The volume has reduced. So the temperature should increase. Yes, that's the way how you do problem. Pump garam ho jayega abhi aapka. This will be test for Asmita. Now she has to report temperature. And finally report the temperature in Celsius. Okay. I want the temperature in Celsius. Final answer. I want T2 to be reported in degrees Celsius. If you don't follow steps, you'll fall off the steps. And Nidhi, overall, after the rains, how did you find the roads? Typically from Belgaum area onwards, Karnataka?
I know it's a steep area.
You keep doing chemistry problem. You all are all a special species on this earth. We don't have the whole day. Temperature. You're kidding? How can you get temperature like that? How the temperature in Celsius? Ish. These people na, you all will drown me in river. हाँ बोलो ध्रुव कितना आया?
I think it's not, is it 36?
There is nothing called I think. You say what is your answer? 36 what? My head? My head or your head?
26 degrees Celsius.
Okay, Kirtan, do you agree with this or not?
Yeah, 36.
Hey, yeah, 36.
Yeah.
You got 36 or you are just paraphrasing him?
No, 36.
Ashmita has switched off the camera. That's the best thing that she can do. Camera hi band kar do. Kya zarurat hai? He keeps on looking at me.
No, sir, this
So we have to find our T2. So how do you find T2 from here? But get the expression first. If you take T2 on this side, if I take T2 on this side, I get P2 V2 T1 divided by P1 V1. Have you got a hang of this expression now? If T2 goes this side, then this is the expression, right? So let's find T2, and obviously our answer will come out in Kelvin. What is the pressure? P2 is 3.2 raised to 10 to the power 5 Pascal. Okay, multiplied by V2, which is 30 centimeter cube, multiplied by T1, which is 300 Kelvin. This is 300 Kelvin. Ashmita, not 296.6, huh? 300 Kelvin. Divided by P1. P1 pressure is 2 into 10 to the power 5 Pascal. Multiplied by V1, which is 40 centimeter cube. Centimeter cube gone. Pascal gone. 10 to the power 5 gone. So 2 multiplied by this is 1.6. And then 0 and 0 gone. And 4 fours are 16. So 0.4 gives you 1.6. 0.4 into 3 will give you how much? This will give you 1 point. So let's multiply this. This is 900 Kelvin, which is being multiplied by 0.4. So 4 nines are 36, 00, and this gone. So 360 Kelvin, which is minus 273, should give you 7, and 1 and 7, 8, 8 and 6 is 8, and so it should be 87 degrees Celsius. 360 Kelvin. 360 Kelvin is, yeah. Check now. I didn't use calculator, huh? Check कर ध्रुव. Three threes are 9, 900, 9 fours are 36. So 3600, 360 Kelvin. 360 is. Did you get 360 Kelvin or not? Hey Kirtan, what did you say? I also got that same. Let me get a hold of this fellow. How much did you get it in Kelvin? First of all, tell me. He did not do itself. He was just saying, Dhruv will, to Dhruv ka answer to right niklega. Whatever he says, I will say that. Dhruv got the answer as so many Ravan Kelvin. He also said Ravan Kelvin.
I think I got 36 Kelvin, 36.
Hey, how can you get 36 Kelvin?
Okay.
0.4 multiplied by 900. 4 into 900 is 493600. 0.4 means 1 gone. Did you get 360 Kelvin or not? क्या तू मुंडी हिला रहा है रे? इधर देख तो इधर देख, इधर देख. ये एक्सप्रेशन ठीक है? 3.2 into 10 to the power 5 into 30 into 300, 2 into 10 to the power 5 into 40. समझ में आया? 10 to the power पीटना चाहिए ना तुम लोगों को. 10 to the power 5 strikes off 10 to the power 5. Agreed? 2 strikes 32 off as 1.6. 16 twos are 32. So 1.6 is. Did you get it?
Yeah.
4, 0 and this one gone. And 4 fours are 16. That means इसको काटेंगे तो 0.4 होगा.
Okay.
So you are now left with 0.4. 3 multiplied by 300 is 900.
Yeah.
4 multiplied by 900 is 3600. But you are multiplying 0.4. So point यहाँ पे कट जाएगा.
Oh, yeah.
Oh yeah. तो कितना हुआ? 360 केल्विन हुआ कि नहीं?
Yeah.
और 360 केल्विन से 273 निकाल लो तो सेल्सियस में आंसर आ जाएगा. What happened, Ashmita?
Sir, I got the answer to the last question. So it is 1.86 into 10 to the power 7 Pascal.
No, still it is wrong.
So what is the answer?
No, because you, the problem with you is what, Ashmita, you know, you hunt for the answer. You don't go by logic. आप सीधा logic लगाओ ना. आपका last question में it came out as 31 upon 30, which I said is almost equal to 1 into 1 by 5 था. याद है? Into 10 to the power 5. This was the expression. This thing is approximately 1. 1 divided by 5 is approximately 0.2. So 0.2 multiplied by 10 to the power 5. ये आंसर आना चाहिए.
Okay.
आप लॉजिक नहीं लगा के इतना देर, that means this problem you didn't do at all. What answer you got?
So I got 87 degrees. I did it right.
Achha, wow, good. Now Nidhi has switched off camera. They think they are like, you know, crows have that habit. A crow as a bird closes his or her eyes thinking that the world doesn't see the crow. Just because the crow is not able to see you, the crow thinks the world is also not seeing the crow. And did you get the answer or not? Somebody is using kasuri methi. Yes or no? Yeah, they've just crushed it on hand. Shall we? Next problem. And the best was Kirtan. Yes, sir. Yes, sir. I got 36. Yeah. 36. Yes. Kal Dhruv bolega, I got Ghatotkach. He will also say, I got Ghatotkach. Chale, next problem. Now, these are exam style questions. Shall I? Ladies and gentlemen, do you have the permission to go ahead?
Yes, sir.
Okay, right. Thank you for permitting me. Please, the next problem. Now the problems we are getting would be, some part would be theory, some part would be numerical. I'm taking the numerical. So can somebody tell me what is the significance of a temperature? What is the significance of this temperature 273 degrees centigrade in terms of particle motion? What do you understand? What should be your answer? There should be no kinetic energy, so the particles do not have any motion. Their motion have ceased. This is called the absolute zero. What is this temperature? This temperature is same as getting a temperature of how much? Absolute zero. That is 0 Kelvin. And at 0 Kelvin, the internal energy has almost become zero. No kinetic energy. So all the particles' motions have ceased. Zero is the motion. Okay, good. कुछ तो पढ़ा है घर पे. Now the next question. State the value of the temperature of minus 273 degrees Celsius on the Kelvin scale. On the Kelvin scale, what should be the temperature? 0 Kelvin, which is also known as the absolute zero. Okay. Calculate the value of temperature of minus 200 on the Kelvin scale. So now you have to calculate minus 200 degrees Celsius. This corresponds to how many Kelvin? Zero Kelvin, enta, sir. Oh no, 0 degrees Celsius. 0 degrees Celsius corresponds to minus 273. Oof. 273 Kelvin. In Kelvin, there is nothing called minus. You always remember that. So you're coming down by how much? Negative 200. Come down by negative 200. 73 Kelvin. Ashmita is still solving, by the way. Did you get the answer or not?
Yes.
Okay. So let's take one more problem. This is an exam problem. So I think this will be a 6-mark question. It's a 6-mark question. So it has a diagram. Let's make the diagram first. So I have a piston out here. We have a piston. Right, this is my piston, and this much is 30 and 10 centimeter. Okay, very good. So this much is, so this is 30 cm and this is 10 cm. Okay, 30 cm and 10 cm. This is a cylinder, there's a piston. Okay, this is the data that is given, and right, this section is y and this section is x. I'm going to read out the question now for you. The piston is pulled out of the cylinder from position x to position y. So what did we do? We pulled out the piston. Have we increased the volume now? Yes, we have increased the volume. The piston has moved out. Okay, the piston has moved out from this position x to position y, and there has been no change in temperature of the air enclosed. If the original pressure of the cylinder, so the original pressure, let's say P1 is the original pressure, and this pressure is 1 into 10 to the power 1 into 10 to the power 5 Pascal. Okay, they're asking you to calculate the pressure when the piston is at y. The pressure when the piston is at y. This was the pressure when the piston was at x. इसको कैसे करेंगे? Now this is a cylinder. Cylinder's volume is how? Cylinder's volume is always cross-sectional area. You actually don't need the cross-sectional area. No, 40 नहीं 40 नहीं. वहां पे गड़बड़ी मत कीजिए. Let the cross-sectional area of the cylinder be a centimeter square. Have you understood? Right? Volume is what? Cross-sectional area into displacement. कट जाएगा आपका. Now they have asked us pressure and okay, so we will need to find out what should be our V1. What should be our V1? Our V1 should be 10 times of a centimeter cube. Do you agree or not? Because initially the piston was here. When the piston is here, this is your initial volume. This is the initial volume, V1. And V1 should be equal to 10 into a centimeter square centimeter should give you centimeter cube. How many of you have understood this? This is the initial volume. Got it? Okay, fine. What should be your final volume? You have withdrawn it from there till here. Now your stroke length is how much? 40. 30 plus the original 10. Good. So it's how much? 40 a centimeter cube. Did you understand why is it 40? Final volume. यहाँ से यहाँ तक मत गिनना, लड्डू मिलेगा. ये भी तो volume है, right? So which law will we apply? Boyle's law. So Boyle's law tells me that P1 V1 should always be equal to P2 V2. Now we have to find out what P2. P2 is a P1 V1 upon V2. What is P1? 1 into 10 to the power 5 Pascal divided by, okay, with this V1 should also be there. V1 is how much? 10a centimeter cube divided by 40a centimeter cube. So a and a strike each other, centimeter cube gone. 0 takes away 40 means 4. Yeah, 0 takes away 10. So 1, so it is 0.25 atmosphere. Or you can say 0.25 into 10 to the power 5. Very good. Next part of the question is the air pressure when the piston has moved further 10 centimeter to left of y. The piston has now moved further 10 centimeter, it has gone to the left of y. Now what should be the air pressure? How? Calculate it. PV. Yeah. So that's correct. 0.2. All of you understood this part? 3 marks, 6 marks is the grade for this particular problem. Tough nahi hai. Anyone who has not understood? Kirtan, did you understand or not?
So it's the last part again, like when it's increased to 10 centimeters.
So when it is increased to 10 centimeter, you take your new data again. आप अपना न्यू डेटा ले लो. अगर आपको ऐसे कंफ्यूज हो रहा है, no worries, you take your new data. Let's take our new data. No. So that's what I'm saying. Let us take the new data. So it has gone by 10 centimeters, right? So they have asked you what? How much should be the pressure? Pressure. So we will take data 2 as our data 1 now. So let's take, okay, let's take, what was the P2 that you found? 0.25 into 10 to the power 5 Pascal. What was V2 beta? 40 A centimeter cube. What is V3? Another 10 centimeters. As V3 has become how much now? 50 A centimeter cube. Agreed? And you have to find out what is P3 equal to. So P3 V3 equals to P2 V2. So P3 should be equal to P2 V2 upon V3. P2 का value कितना है? 0.25, which is 1 by 4 into 10 to the power 5. Right? And V2 का value कितना है? 40A cm cube divided by V3, which is 50A cm cube. cm cube, A gone, 0, 0 gone. So all you have 4, 4 and 4 gone. So 1 divided by 5, which should be 0.2 into 10 to the power 5 Pascal. You don't need calculator at all.
Yes.
Yeah, sir. Calculator for her is like ventilator in ICU. You take away calculator, Rashmita will be. Then again restore her back. Okay, let's go to the next one. Okay, one more problem before we call it a day, so that I'm very happy. We have done a lot of problems today. So our next problem is again an exam type question, and it's about gas. And they say a certain quantity of gas. Okay, this is a certain quantity of gas, and this certain quantity of gas has a volume. This has a volume of 30 centimeter cube, and at that time the pressure is 1 into 10 to the power 5 Pascal. Okay, and assuming that the temperature remains constant, so again it's Boyle's law, temperature remains constant, and calculate the volume of the gas when the pressure is, there are two different pressures. So the pressure has been made 2 into 10 to the power 5. Chal, Sasra, tell me. So it should be 15 centimeter cube. And the next one, the pressure has been made 5 into 10 to the power 5. So reduce it by 5, it should be 6 centimeter cube. Yes, very good. Superb. I'm very happy. Can I give you one homework then? Your homework will be, take out the problems from your workbook and do it. Number 1, all numericals. Ye chapter ka numerical mat chodo. This is a sure shot marks that you'll get. And there is a ATP question out here. So your homework is, then I'll leave you. Kirtan will say today, my drum sir se bhi pehle choda. So your question is, there's an ATP question. And if somebody doesn't get the ATP question, I can send the picture also. But anyways, you don't see Skype. So ATP questions, and take the questions from your workbook so that in the next class we can proceed to the new chapter. Fine. Quadratic equations, second exercise, word problems we'll do. If there are any word problems pending from the first exercise, have a look and come. Don't come to the class in a reactive mode. Come plan. All festivals are going away. From now, children, we have to be CBSE. Already the dates have been announced for finals, grade 10. They start from February 10. So this is an alarm for you. Feb 15 and it ends on March 25. March 25. And you know what happens to IGCSE? IGCSE will be over by 29 Feb. Your exams will be over in grade 10. That means in grade 9, your exams will be over even before this. And we usually I start my grade 10 from 1st of March. 9, I start from 1st of April. I mean, you don't have much time. February, maybe I will not coach you all at all. You have to study on your own. So we only have how much? October half gone. November, December, Jan. and we have to finish our 9th syllabus. So children, we cannot afford now that in the maths class here I'll say do 23, 24, 25. I'm going to teach you. You have 7 days. Come back prepared, sir. I could not do these 2 problems. Fine. I knock them off in class and we move to the next. Right? We have to press the accelerator. बहुत मस्ती कर लिया. Initially we were at a good speed. Then we lost quite a bit of time. And from now on, preferably don't miss classes. I know there's a video. वैसा होने से तो वीडियो देख देख के पढ़ लेते. क्लास टीचर की क्या जरूरत है? ठीक है? चलो. See you all. Kirtan, happy drumming time. Little bit of snacks time before you drum up. Right.